Today we'll be going over speed and velocity. And starting with speed, speed is a scalar quantity, and the variable used for it, or that we'll be using, is a v without a vector hat, just because it is a scalar. And so speed is just how quickly an object is moving with no concern about direction. And so generally we're going to be finding average speed. Okay, and the way that we find this is by dividing the total distance divided by the total time. So generally we're going to be calculating speed whenever no direction is actually given in the problem. So if there's no direction, that means that we're trying to find speed, which is denoted with the variable v. Okay, so to find average speed, so the AV subscript is showing that it's the average. It is the distance, total distance, over change in time, or total time. Okay, so distance is either going to be given in meters or kilometers. Most often, time is going to be seconds or hours most of the time. Okay, so that would make that our average speed is either going to be meters per second or kilometers per hour. Okay, so the units for this can change just based on the question that is being asked of you, so just make sure that you're paying attention to that, and make sure too that your units all match before you start solving any of the problems, because sometimes you might have to convert say hours to seconds or seconds to hours and things like that. So just make sure that you're paying attention to the units in the given problem. Okay, moving on to velocity. Velocity is a vector, and so we denote it with a v with a hat on top. Okay, so this is the rate of change in position. And it's found by dividing the displacement divided by the elapsed time for that displacement to occur. Okay, so we're going to calculate it when direction matters. Compared to speed, remember that's whenever no direction is given. So this direction actually matters. So this for the average velocity, and putting on a hat just because it is a vector. Okay, we're going to have displacement, which remember displacement is the change in position, and it is a vector, over the change in time. Okay, so like before, the units are generally going to be meters or kilometers for our displacement. Our time is going to be seconds or hours generally. And so that means that our average velocity is generally going to be meters per second or kilometers per hour. Okay, so running through the example of average speed, runner Usain Bolt ran the 100-meter dash in 9.58 seconds. What was his average speed? So the distance he traveled was 100 meters. The total time was 9.58 seconds. And we're trying to find the average speed. Okay, so this is what we're trying to solve. Our formula, we have speed is distance over change in time or total time. So plugging in our variables, we have the distance, 100 meters over 9.58 seconds, and we should find that his average speed was 10.438 meters per second. Okay. Moving on to the example with velocity. A plane travels 376 kilometers southeast in 5.2 hours. What was the plane's average velocity? So our total displacement was 376 kilometers southeast. Okay, don't forget the direction. It's important whenever we're looking at displacement. The total time elapsed was 5.2 hours. Okay, and we're trying to find the average velocity. Okay, so our formula is displacement over total time. Plug in the variables. We have 376 kilometers southeast, all over 5.2 hours. Okay, so that comes out to be 72.31 kilometers per hour, and it is southeast. Okay, so this is the proper way to format the answer for that one.